Hello, Mr. Zonker here. This video is on more complex exponent problems. Not more as in more of them, just the ones we're doing are a little more complex than the basic rules we've been talking about so far. First off, I want you to know all rules apply the same to variable expressions, and if rules are applied correctly, the order does not matter. If you stick to your math rules, you stick to the logical sense of the way things work, the problems will work out. Here are some quick tips to make solving simpler. Go ahead and just note those for now, and then they'll make a little bit more sense as we get into some examples. First, do not apply exponent rules to regular numbers without exponents. That's why they're exponent rules. There has to be exponents to apply them. Evaluate powers of powers first. Evaluate each different base separately. Flip the negative exponents to the other side of the fraction. And then lastly, if you are getting mixed up on your rules, it's always a good idea to expand them if needed so you don't mix those up. If you can expand it, your brain can kind of comprehend what's going on a little bit easier. Alright, we're going to do 4 examples. Try not to be intimidated. They might look a little scary at first, but they're actually not too bad. Let's take a look at this first one here. We've got 3x squared y z to the 5th times 4x to the 3rd y to the 3rd. And what we're going to do is we're going to take each of these separately. Let's start with these numbers. If I do 3 times 4, well, that's going to be 12. Okay, not that bad. Now I'm going to hone in on my separate bases. I've got x squared. Over here on the other side, I'm multiplying by an x to the 3rd. That exponent rule, I have 2 x's, then 3 more x's. That's going to be x to the 5th. My y variable here is I've got a y, which when there's no exponent, that's just 1y. A y to the 3rd, that's going to be y to the 4th. And then lastly, we have that z to the 5th. Notice there's no z on the other side, so their only base of z is that z to the 5th. We're still left with that. So this would be our answer. Moving on, here we have, in parentheses, 2a squared c to the 3rd all to the 3rd power. If I was going to expand that, that would be 2a squared c to the 3rd times 2ac to the 3rd times 2ac to the 3rd. Whenever we have parentheses here, this power is going to apply to everything. I always think it's not a bad idea until you really know what you're doing to put in a little 1 when you're lacking an exponent, kind of like we did in the last example. My power to a power rule is multiplying. I'm going to apply that 3 to 1 at a time. So 1 times 3, that's going to give us a 2 to the 3rd. Next, I'm going to take my next variable, a squared to the 3rd power. 2 times 3 is 6. A to the 6th. And lastly, I have my c to the 3rd power to the 3rd power. 3 times 3 is 9. That's going to give us c to the 9th. And that would be our answer right there. Here we go. We're dealing with fractions now. Again, let's focus on one thing at a time. If I'm starting with this 14 over 6, I can simplify that. Divide 2, top and bottom. That's going to give us 7/3. And you know, it's not a bad idea to extend that fraction bar because we're going to be working more with other things. Next, don't worry about the numbers anymore. We're done with those. Let's focus on the t variable. T to the 4th divided by t squared. 4 on top, 2 on the bottom. 2 are going to cancel. We're going to be left with 2 squared on the top. My last variable, v to the 5th over v to the 7. I have 5 on top, 7 on the bottom. If 5 cancel, we're going to be left with 2 on the bottom, v squared. And this would be our final answer. 7/3 t squared over v squared. Last example here. I personally think it's simplest to take care of the negatives first. Now you could use your subtraction rules and then flip things from there. But I like to just put them on the right side so that we're only working with positives. This a to the negative 2, I'm going to flip that to the bottom. Let me draw my fraction bar. So I've got a to the positive 2 down there now. My a to the 4, that's a positive exponent. So we're going to leave that in the denominator. So we'll have a to the 4. Next, I'm going to go ahead and just leave my b variables since I'm working with, want to get rid of my negative exponents first. Here I've got a c to the negative 8. That's going to flip to the other side. C to the positive 8. And I've got a c negative 6. That'll flip to the top. That's going to be a c to the positive 6. All right. From there, let's take one variable at a time. I'm just going to draw my fraction bar. Give myself a little more room here. My a variable, well, I've got 2 on the bottom here, 4 more on the bottom. That's going to give us 6 total in the denominator. Now my b to the 4 terms. B to the 4 over b to the 4. Well, if I divide b to the 4 by itself, that's just going to be a 1. I'm going to cancel those out for now. Lastly, I have c6 over c8. I have 2 more on the bottom, so if I cancel out 6, I'll be left with 2. And when there's nothing else left on the top of the fraction, the numerator, we can't just leave that blank, so I'll just put a 1 there. So this would simplify to 1 over a to the 6 times c squared. The best way to practice these is to just try them out, try some different rules, check your answers as you're going, and as you practice more, you start getting the hang of them, and then you'll find that you can kind of work on them fairly quickly. All right, hope this video has been helpful.